Azure Cosmos DB, Data Management. Database. In Azure Cosmos DB, a database is the highest level organizational unit that acts as a logical container for a group of collections and containers. Each Cosmos DB account can have multiple databases. 1. Partitioning. Each database can have its own partitioning strategy, enabling you to distribute data across multiple servers for enhanced performance. 2. Throughput allocation. You can allocate throughput at the database level, which is then shared among all the collections within that database. Collection. A collection in Cosmos DB is somewhat akin to a table in relational databases, but it offers greater flexibility and features. 1. Schema agnostic. Collections do not enforce schema constraints, providing the freedom to store documents of varied structures. 2. Indexing policy. Each collection can have its own indexing policy, thus providing fine-grained control over query performance. 3. TTL, time to live. Collections can have a TTL setting that will automatically remove documents that exceed a specific age. Containers. Containers are the abstraction for storing different types of data items in Cosmos DB. A container can hold documents, graph vertices and edges, or key-value pairs depending on your chosen API. 1. Multi-model compatibility. One container can accommodate multiple data models such as key-value, column family, or graph data. 2. Logical partitions. Containers use a partition key to distribute data into logical partitions, which helps in effective data organization and querying. 3. Physical partitions. These are the underlying, system-managed partitions where logical partitions are stored. Cosmos DB automatically handles the management of physical partitions. Relationship among them. A database can contain multiple collections or containers. A collection is essentially a type of container that holds only document data. Containers offer a more generalized form of storage that can accommodate different types of data models. Access control in Azure Cosmos DB. Access control, also commonly referred to as identity and access management, IAM, governs who can do what within your Azure Cosmos DB instance. 1. Role-based access control, RBAC. BAC allows you to assign specific permissions to users, groups, or applications at different scopes: management group, subscription, resource group, or resource. This can be highly tailored to fit your organization's needs. 2. Azure Active Directory, Azure AD. You can integrate Azure Cosmos DB with Azure AD, allowing you to authenticate users and applications using tokens. Master keys. Azure Cosmos DB provides two types of master keys. 1. Read-write key, provides full read and write access to your database account. 2. Read-only key, provides read-only access to your database account, thereby offering a secure way to share your data without the risk of unauthorized modifications. Resource tokens. Resource tokens provide a more granular level of control. These are short-lived, and you can govern access down to the individual container or even item. Identity management. 1. Managed identity. This Azure feature allows Azure services to authenticate to any service that supports Azure AD authentication without any credentials in your code. 2. User-defined identity. You can create a managed identity that is used exclusively by your service. Integration points. Power BI. What? Integration with Power BI allows you to visualize Cosmos DB data. How? You can connect Power BI to Cosmos DB using the ODBC driver. Once connected, you can create visualizations and reports based on your data. Azure Synapse Link. What? Azure Synapse Link creates a tight integration between Azure Cosmos DB and Azure Synapse Analytics. How? You can enable Synapse Link directly from the Azure portal. Once enabled, it allows near real-time analytics over operational data. Azure Cognitive Search. What? This allows you to add full text search capabilities to your Cosmos DB data. How? You can configure Azure Cognitive Search to index your Cosmos DB data directly within the Azure portal, allowing for search capabilities on your data. Azure Function. What? Azure Functions can be used for serverless computing tasks like data movement, event handling, etc. How? You can integrate Azure Functions through the Azure portal, linking your Cosmos DB trigger to the function, thus allowing seamless data manipulation. Data Management tabs. 1. Containers. Containers act as a unit of scalability for your data. You can think of them like tables in a relational database, but much more flexible. 2. Browse. The Browse section allows you to explore the hierarchical representation of databases, containers, and items within each container, thereby helping in data navigation. 3. Scale. This feature enables you to configure the throughput settings, either manually or automatically. This throughput can be scaled without affecting the availability of the database. 4. Settings. This tab allows you to configure various database settings like indexing policies, time to live, and partition keys. 5. Document Explorer. Here, you can examine the actual documents stored in your container. You can also perform CRUD operations directly. 6. Query Explorer. This is your interface for running SQL queries against your data. It's an excellent tool for testing and debugging. 7. Script Explorer allows you to manage stored procedures, triggers, and user-defined functions, UDFs. Summary. Database, top-level organizational unit, supports partitioning, and allows throughput allocation. Collection, schema-agnostic, customizable indexing, and supports TTL. Containers, multi-model data storage, use logical partitions for data distribution, and are managed over physical partitions. Access control, achieved via back and Azure AD integration. Master keys, 2 types, read-write and read-only. Resource tokens, granular, short-lived tokens for specific access. Identity management, managed identity and user-defined identity options. Use cases, ideal for multi-tenancy, audit and compliance, and serverless applications. Thanks for watching.